All right, number two. Despite their size and awkward appearance, polar bears can run at respectable speeds for short distances. Suppose a polar bear running with an initial speed of 4 meters per second accelerates uniformly for 18 seconds. What is the bear's maximum speed if the bear travels 135 meters during the 18 seconds of acceleration? Give the answer in both meters per second and kilometers per hour. This should not be a question mark. All right, so I'm going to be doing this calculation one time, and then I'm going to convert my final answer into the other set of units, right? So I'm going to be reporting two things as my final answer, but I'm only doing the calculation once, and then I do a conversion. So some things that I know. I know that my initial velocity is right here, 4.0 meters per second. I have a delta t right here. That is 18 seconds. I can tell right now I'm working with two sig figs for the most part, so I'll keep that in mind for later. And then I'm also given a delta x. So delta x is equal to 135 meters. Now for this setup, I am calculating a final speed, right? A final speed. Now you might be confused because the problem itself says a maximum speed, right? So how are you supposed to differentiate between maximum speed and final speed? Because we're only paying attention to the 8 seconds, right? There's a frame of reference that's given to you by the question, and it stops at 18 seconds. So that maximum speed is at the end of the 18 seconds of acceleration because we don't know anything after that, right? Maybe just come to a complete stop. Maybe he runs into a glacier wall and comes to immediate stop, right? I don't know. We're only paying attention to that maximum speed at the end of the 18-second acceleration, which is the same thing as saying final speed or final velocity. All right. Now, in number one on this same homework, I have already solved for final velocity, so I hope the equation is nice and handy for you. Minus initial velocity. Now I can plug and chug. 35 meters, all divided by 18 seconds. I'm going to subtract the 4 meters per second. Now this is going to end up, again, with two sig figs, be 11 meters per second. Now, the question has asked me to report meters per second and kilometers per second. So, again, my final velocity is 11 meters per second. So I'm going to set up a conversion factor that allows me to convert out of seconds by putting seconds on the numerator of the conversion factor. Okay, there's 3,600 seconds in an hour. That's going to allow me to cancel out of seconds. Notice that as a result of this calculation by itself, as it's written, this is going to be meters per hour. Meters per hour. So I'm not done yet. I need to cancel out of this hour. So not hour. I want hour. Sorry. Meters. I need to cancel out of meters. So I need meters on the bottom here, and I'm supposed to be converting into kilometers. So how do I equate kilometers and meters? For every 1 kilometer, there's 10 to the third, or 1,000 meters. Now, meters will cancel here, and so the only unit I'll have left is kilometers per hour, just like the question once. .0 times 10 to the first kilometers per hour, which is the same thing as 40 kilometers per hour. Either or is fine. The only issue I would have is if you wrote this. Can you guys tell me why I would not like this? What about this do I not like? In a grand scheme, yes, but that doesn't make... I mean, you're absolutely right. I do want you to get used to scientific notation because it makes things easier in the long run, but that wouldn't make this number incorrect. There actually is something about this that makes this value incorrect. The decimal, or the lack thereof. As it stands right now, 40 as I've written it here, has one significant figure. Okay? In order to make this have two significant figures, I would need to have a decimal there, which makes that trailing zero significant. Okay? Whenever you're doing a calculation with multiplication and division, you cannot have more significant figures in your answer than the measurement with the fewest significant figures. So I have 3 measurements here, right? This one has 3, this one has 2, this one has 2. So my answer cannot have more than 2, right? Um, that precision is limited by these 2 measurements right here. Fair enough? Uh, oh, and get full credit because you're not. What's wrong with having less than 2 in the functionally you'd be communicating less information than you have access to, right? It would be in this it would kind of be in the same realm of, if I ask for a vector quantity and you don't include direction, right? You gave me a speed and that's great, for example, but if you don't give me a direction, you haven't given me as much information as you have access to. That would that would be kind of conceptually the idea.